give an overview. Good evening, ladies and gentlemen. Today I have with us Mr. Hertz. Do you care to go ahead and tell us your full name and a little bit about your project?
My name is Gustav Hertz, and I conducted what is better known as the Franck-Hertz experiment. And what we did with this experiment was proved that quantum energy states in atoms exist. And we did this by accelerating electrons through a glass envelope that was vacuum sealed and contained mercury gas. And the way we did this was we took a cathode and an anode and accelerated electrons past a metal grid. And as we increased the voltage in the tube, the current slightly increased as we went up. And whenever we reached a voltage potential of 4.9 volts, the current sharply dropped to 0. And what this tells us is that 4.9 volts was the amount of energy that was required to ionize the mercury atoms, the mercury gas atoms within the tube. So then that excited the electrons into a higher quantum energy state, which therefore means the electrons are more loosely bound to that atom, and the faster moving electrons can now collide with those mercury atoms inelastically.
So, for myself and for the folks back home, can you boil it down and tell us exactly what you're trying to find?
Well, what we were trying to find was that there are these quantum energy levels within the atoms. Basically, we showed this by, as we increased the voltage from 0 to 4.9 volts, the electrons flowed freely in through the glass envelope, meaning that the mercury atoms, the electrons in the mercury atoms were in a lower quantum energy state, letting the slower electrons pass by them, colliding elastically with them to where they can change speed or change direction, but not speed, and keep flowing by.
Interesting. So, just to get a little bit of background about like when this project was taking place and where, do you know anything about that?
This project took place in 1914. Some other things that were going on around the world at this time where World War I happened shortly after this experiment was discovered, and Einstein shortly after proved relativity.
Interesting. Was there anybody else that was involved in this project?
Yes, me and my colleague James Franck conducted this experiment.
Interesting. So with the two of you working, what was your role and what was his role?
Our roles were pretty much similar. We're both trying to achieve the same end goal, and that was to study electron impact and ionization of gas atoms.
Interesting. So, do you think that your project kind of developed an overall impact in the physics community?
Oh yes, because previously, the year before, Niels Bohr had came out with his model of the atom, which showed that electrons took up mostly empty space in the atom, and that's basically what we showed with our showing of the quantum energy levels. And even after, the year after, Einstein said about our experiment, it's so beautiful, it makes you want to cry.
I'd agree. So with a project like this and to the prestige it was, did you guys ever get recognized within the science community for your achievements?
Yes, actually, the year after, we won the Nobel Prize.
Wow, really?
Yes.
Wow. What year was that?
1915.
Jeez.
That's gonna have to work.